Let us discuss this example. Convert the following linear programming problem to standard form. This linear programming problem to standard form. How can we convert it? Remember in our previous lesson in programming problem, I said in the video that whenever we are converting a LPP to standard form, the first step is what? By adding a slash variable to it. And the reason why we are adding a slash variable to it is to what? To remove what? Unused resources. That is to remove unused resources. And adding slash variable to the constraint and to the objective function, it will change the inequality sign to what? Equality. So let's start from example 1. We have been given an objective function and subject to the constraint. This is our objective function, that is we are maximizing z subject to the constraint. This is first constraint, second constraint, and third constraint. We have what? We have the slash variable to the objective function. So we are going to have, we maximize z 22x1 plus 6x2 plus 2x3. If you decision variable here, we have x1, we have x2, we have x3. And whenever we have less than or equal to, we are going to add, whenever we have anything less than or equal to, the type of variable we are going to add to it is slash variable. So we are going to have, since it is, the decision variable is x1, x2, x3, we are going to have three slash variable, that is x1 plus x2 plus x3, subject to 10x1 plus 2x2 plus x3. First constraint will take x1, second constraint will take x2, and the last constraint will take x3. So we are going to have 10x1 plus 2x2 plus x3 plus x1. Since we are adding slash variable to it, and the slash variable we add to it is what? x1, x2, x3, it will change the inequality sign to equality, is equal to 100. Then second constraint, we have 7x1 plus 3x2 plus 2x3 plus what? x2 is equal to what? 72. Then the last constraint is 3x1 plus 34x2 plus x3 plus what? Slash variable 3, which is what? 80. Then this is our non-negativity. So we are going to have x1, x2, x3. That is our non-negativity here. Non-negative here, that is the coefficient of what? x1, x2, x3. They are what? They are non-negativity, that is they are greater than or equal to what? 0. Then as well to what? The slash variable that we added to it. So we are going to have x1, x2, x3. Then the slash variable x1, x2, x3 greater than or equal to 0. These are non-negative. So we have converted what? So therefore we have converted the linear programming problem to standard form. Let's go to example 2. We have to maximize z 200x1 plus 300x2 subject to the constraint. This is the first constraint, second constraint, and this is what? Non-negativity. So let's start from the objective function. Remember, it is less than or equal to, and the variable we are going to add to it is slash variable. 200x1 plus 300x2. The decision variable we are having here is 2. That is the number of inputs we are having here is x1, x2. So the slash variable we are going to add to it is x1 and x2 plus x1 plus x2. Subject to first constraint, we have x1 plus x2. Then first constraint will take a slash variable 1 plus x1 is equal to less than or equal to, we change to what? Equality, because what is a slash variable. Since we have added slash variable to it, it will change the inequality sign to what? Equality is equal to 8. Then second constraint, we have x1 plus, we don't have for x2, so we don't need to add x2 here. So let us just add our slash variable 2 to it plus x2. Since we don't have, then is equal to what? Is equal to 7. And our non-negativity constraint is x1, x2, and our slash variable, we added slash variable x1 and x2 to it. x1 x2 is greater than or equal to 0. So since we are already doing the slide to show, it means we have converted this linear programming problem to standard form. And also, don't forget, whenever we have less than or equal to, we have this slide we're able to use. So above this linear programming problem above has been solved. That is, we have converted it to what? Standard form. Don't forget to share, likes, and comment.